Hi everyone, welcome back to PW English. Friends, as you know, we have started a new batch which is freely available on YouTube and on PW app by the name UMEED NEET English batch. In this batch, we are completing each and every chapter in one shot lectures, right? So we are completing all the theoretical concepts, all the important points along with their numericals, right? So in today's class, we are going to complete motion in a plane. We have already talked about basic mathematics and calculus, and we have completed also vectors in the same chapter. Then we completed motion in a straight line. Today we are going to talk about motion in a plane, which is also known as two-dimensional motion, projectile motion, right? So before starting today's class, it would be very important that you must complete the basic mathematics chapter, right? Especially the vectors, because we are going to use vectors extensively in motion in two-dimensional plane. So in today's class, the topics that we are going to cover is projectile motion. We are going to first describe, we are going to first define what do we really mean by projectile motion, although we have already done this in the first chapter, but still again we are going to do it. Then there are going to be several cases. The first case is going to be ground to ground. What do you mean by ground to ground? That the projectile is being projected from ground and it lands back to the ground, right? Inside under this this is going to be your case 1. Under case 1, we are going to talk about coordinate of a particle at any point at any time t, right? We are going to talk about equation of trajectory, what is equation of trajectory, we are going to also figure it out. Then height to ground is going to be the another case. So this is your another case when projectile is being projected from a certain height and it lands back to a ground, right? Then we are going to talk about relative motion in 1D and relative motion in 2D. So in relative motion in 2D, we have got like two separate problems: rain man problems and river boat problems. The rain man problems are also sometimes known as, when rail man is known as by rain man only, but river boat is sometimes known as river man problem, swimmer river problem, and so something like that, right? So let's start today's class. Let's start with what do we really mean by projectile motion. Now we know that if a body changes its position with respect to time, we state that the body is in motion with respect to time and some reference point, right? And if you remember, in the first class we also talked about if we are saying that we are talking about position of a particle, right? If we are saying that we have got a position of a particle, something like, let's say the position of the particle is x comma y comma z, right? So if only one coordinates changes, we are going to say that okay, so this is a one-dimensional motion. If two coordinates are going to change, we are going to say that this is a motion in a plane or projectile motion, right? Or motion in two dimension. So now what we are going to do is, before starting the projectile motion, let me first clarify, let me first explain this, that we are not starting any new chapter, right? So we are going to talk about everything that we have already learned in the previous chapter, that is motion in a straight line. We are not going to talk about anything new. So it's just a revision of whatever we have learned in the in motion in a straight line, right? The only difference is, now what we are going to do is, generally we are going to say that, let's suppose we have got a particle something like this, right? We are not going to talk about mass of this particle because right now we are dealing with kinematics. Let's say it has got a velocity something like this, right? So you are going to say that okay, this body has got velocity only in y direction. Is that correct? So if this body has got velocity only in y direction, this body will only move in this particular direction. It makes sense, right? This is a one-dimensional motion. Similarly, we can have several other examples. Let's suppose that we have got a similar type of a body, but now this body is moving something like this in x direction, right? Let's say it has got velocity in x direction. So you are going to say that the velocity of this particle is only along y direction. It has got no other component along any other axis. It has only one component, it has only got velocity in one direction, and that is in y direction. So it will actually travel along y direction only. And similarly, you can say the same thing for this one. Only difference is we are going to say that this body is going to travel in x direction. Is that correct? So these are the two examples of one-dimensional motion, and we have been dealing with questions like these. We have been applying equations of kinematics to problems like these, right? Finding out the time of flight. What do you mean by time of flight? Let's say we are going to, of course, talk about time of flight for this case. We are going to say the time taken by the particle to reach back to the ground is time of flight. We have talked about finding out what is the maximum height, right? So same thing we are going to repeat it over here as well. The only difference is now we are going to actually do all the things twice. We are going to combine these two motions, right? What I really mean to say is now in projectile motion, the body will have actually component of velocity in two directions at the same time, right? So initially we said that okay, we are going to only discuss about this in one dimension, and we are going to state that this is a one-dimensional motion. We are going to only talk about particle like this, and we are going to say that this is a one-dimensional motion. But when we are going to combine these two problems, we are going to say okay, now the body has got velocity also in x direction, it has got also velocity in y direction. Now this is a projectile motion or a two-dimensional case. So this is actually very, very easy, right? The only prerequisite that you must know is, let's suppose that okay, we have got an x-axis like this, we have got a y-axis like this, and if we have got a velocity something like this, this is a velocity vector, and let's say velocity vector is denoted by vector u, and it makes an angle theta with the horizontal axis or the x-axis, something like this, right? The only thing that you must be really quick and see, if you really don't know, whenever I teach, I start from the very basics and then we cover all the essential topics, all the essential concepts. So the very basic thing is, please be really quick, be really comfortable in finding out the components of any vector quantity, right? So if we have got a vector quantity something like this, then what we are going to do is we are going to actually say that this is the horizontal component and this is going to be the vertical component of the velocity vector. So I'm going to call this as ux, and this is going to be u cos theta. If you want to write it in vector form, you are going to write ux is equals to u cos theta I cap, and similarly this will be written as u sin theta along y-axis, right? Written by u sin theta j cap. Hopefully everything is clear till here. Velocity is a vector quantity, so in anywhere if they tell you to find out the velocity of a particle, we have to find out two things. One is magnitude of the velocity, which is going to be u, and the another thing is angle. So this should be very, very clear to all of you, right? Now after this, let's start with the case 1, that is ground to ground projection, and now let's talk about each and everything. So for ground to ground projections, my friend, what we are going to say is, let's suppose that this is the ground, alright, and we are talking about ground on earth. We are talking about that we are discussing all of these things, and we are stating that this ground is on earth, and we know that on earth we have got an acceleration due to gravity acting downwards, right? And there is no acceleration along x axis. We have, I mean, two things are quite, just a second, I'll just draw it something like this. So we don't have any acceleration along x direction. So acceleration along x direction is 0, and acceleration along y axis is small g. Usually we are going to assume that its value is 10 meter per second square, right? Now the next thing is, so this is very, very important. And why it is very important? Because if acceleration along x-axis is 0, it means that the horizontal component of velocity will never change. Very basic thing, but as soon as we have written it, that acceleration in x direction is 0, let's also write that this means that the horizontal component will never change. Now this will actually, we are going to use these concepts again and again in different questions and in different cases and concepts, right? Also, I mean, definitely if in some of the question they are going to talk about if they'll include air resistance as well, then obviously we can't say the same thing. And always remember, air resistance is not does not act in a single direction. It always acts in the direction opposite to the direction of motion, right? So please note that. Now the thing is, let's suppose that we have got a particle and this is our particle. We are not going to talk about its mass, right? Let's suppose that it is at origin. Let's assume that we have this particle initially was at origin, and when I say initially, I mean to say that at this particular point time is 0, right? And it has got certain initial velocity, and the initial velocity is at an angle of theta. So this is theta, right? Now the thing is, what type of motion are we going to see? Obviously, you all have seen it that the motion of this particle is going to be something like a parabolic path, right? Something like this. I'll draw a slightly bigger diagram. And the initial velocity vector is something like this. And this is angle theta. So as I have stated, we are going to talk about each and every point. What is this theta? Theta is the angle between the horizontal axis, horizontal line, right? This is our horizontal line. I can call this as x-axis, and the initial velocity vector. So obviously, if you are going to talk about angle between the velocity vector and the x-axis, is it going to remain same or is it going to change? So it will always change, right? Why it will always change? Let's talk about it. As we have already discussed, this velocity has got two components. One of the component is something like this. We are going to call it as ux or u cos theta. The another component is uy or u sin theta, right? Now I really don't have any problem with this because this is not going to change. But this velocity is along y direction and I have got an acceleration along y direction whose value is g, right? So that means if I have got an acceleration is rate of change in velocity. That means this velocity will change. And if this velocity will change, the net velocity will change. I mean, velocity is this, u is actually the net of this component and this component, right? So if I'm going to change one of the component, the net vector quantity will get changed, and when the net vector quantity will change, the theta will also change, and if theta will change, we are going to have different angles, right? So theta is only the initial value. So this is very, very important, right? After at any point, if you want to find out the velocity, we will do that. I'm going to solve it for you, right? But for now, let's talk about some different things. Now I really want you to relate this diagram with whatever we have done till here. See, this velocity is responsible for taking the particle in x direction, for moving the particle in x direction. And this velocity is responsible for moving the particle along y direction. So let's not create a confusion. It's very simple. Whenever we are going to talk about the x-axis or the things that are happening on x-axis, we are going to be only concerned with this velocity. We are never going to be concerned with uy or with the vertical component of the velocity, right? So what are going to be those things? So let's suppose we are talking about the particle starts its journey at t equals to 0 and it falls back to the ground, and I want to calculate what is the displacement, the maximum displacement along x-axis. So the maximum displacement along the x-axis is actually known as range, denoted by capital R. Now range is a physical quantity, it is a displacement. But the first thing that we must ask to ourselves is, this range is along which dimension? So you are going to say it is along x dimension. So now I am going to say, okay, so don't worry about anything. For range, the velocity, the component of velocity which is responsible is actually u cos theta, and we have got to do nothing with u sin theta, right? Is that correct? So after this, let's again break down each and everything. What else we are going to talk about? We are going to also talk about something which is called as maximum height. What do we really mean by maximum height? Maximum height is the maximum height attained by the particle, by the projectile. This particle is also known as projectile, by the projectile along its journey, right? So this is the point. Obviously you can see it, this is going to be the maximum height, but you can also say at this particular point, I'm going to again draw the velocity vector, and I should actually not draw the velocity vector something like this, but I'm going to say that, okay, this is actually Vy is actually equals to 0. So there is no velocity vector over here. Please note this point. And actually it is quite logical, because please understand again, maximum height is along which dimension? So it is along the y direction, it is along the vertical axis, right? So which velocity is responsible? U sin theta is responsible. So if you are saying that a body is at its maximum height, it means that it is not going to go any it's not going to reach to a newer height. Is that correct? It means that the velocity which was responsible for it to move along y direction becomes 0. So that's why it is 0. And what about the x component of the velocity? Well, it will always remain same. So I'm going to write Vx is actually equals to ux. Why I'm writing Vx? I'm just writing Vx for the final velocity, right? Now that doesn't mean that I'm talking about the final velocity. You're going to say, but sir, the final velocity should be somewhere over here. Well, I am saying let's just judge these 2 points. So for these 2 points, my friends, the final velocity is here, the initial velocity is over here, right? Hopefully you are getting it. Whenever we talk about final and initial, first let's define for which points are we talking about. So right now I was just talking about this point and this point. So the final, so this will never change. So shall I just write it as ux, right? Shall I just write it as ux? So this will always be u cos theta. Hopefully everything is clear, right? So we have got like 2 things till now. We have got range, we have got maximum height, and we have got also one more thing which is known as time of flight. That means the time taken by the particle to reach back to the ground. So at this particular point, the value of small t will be actually capital T. Well, I am stating it to be capital T. This is known as time of flight. The time taken by the particle to reach back to the ground if it was thrown at t equals to 0. Is that all good? Right? We are going to obviously talk about more things over here. We are going to talk about, like, let's say at any point of time, what is going to be the velocity, how are we going to find out the magnitude of it, how are we going to find out the direction of it, but let's go step by step. So the bottom line of this chapter is, the easiest way to learn this chapter is break down the projectile motion, break down the 2-dimensional motion into 2 1-dimensional motion questions, right? So now what I'm going to talk about is, I've already defined what do we really mean by range, what do we mean by time of flight. So if we are going to talk about time of flight, now time of flight is obviously it is a physical quantity, but it will remain same, isn't it? It will remain same along both the axes. Does it make sense? Right? So we are not going to talk about, okay, so if it is time of flight, how we are going to calculate it. So we are going to actually calculate it using a very good example, from a one-dimensional motion, that we are going to say the time taken by the particle to reach from this point to this point. Let's calculate that time, right? And that time is going to be, mind you, that time we are going to calculate it using the first equation, Vy equals to Uy plus Ay into t, right? And because all of these things are vector quantity, I'm going to put vector signs over here, and I have written the name of the axis in the subscript just to show that I am applying the first equation of kinematics along the y-axis only, right? So for the highest point, Vy becomes 0, Uy is nothing but U sine theta, you can also write it as Uy, acceleration due to gravity is minus g, and time taken by the particle for this is, let's say, it's small t. So small t comes out to be U sine theta by g. Now again I'll go back to this slide and I'll ask you, if let's say time taken by the particle to reach here where the final velocity is 0 is, let's say, it's the time is small t. So the time taken by the particle to reach back to the ground is also going to be small t, and hence the total time is going to be actually twice of this time. Is it clear? We have already done this actually you have already done this in grade 9th also, but anyway we have also discussed this in our previous chapter, right? So the same thing will apply over here as well. I mean, please don't think that, oh sir, but we have got this velocity, so is there going to be any difference in time? Why will be? There will be no difference, right? Why? Because this velocity has got only one job, to move the particle in x direction. And when we are going to talk about the x direction's physical quantity, we are going to include this thing over there, right? Right now we are saying, okay, time taken by the particle to go from here till here is small t. So the time taken by the particle to go from the maximum height again to the ground will also be small t, right? We have not included any air resistance. So therefore, the total time of flight is going to be twice of this, and that is going to be 2u sine theta by g, right? Also can be written as 2uy by g. Hopefully everything is clear till here, right? Now let's move on, and now let's talk about the next point, that is finding out the range. Now I have already discussed it. When we are going to talk about range is actually the maximum displacement traveled along x direction. So I'm going to actually use the second equation, and I'm going to say that, okay, displacement traveled in x direction will be written as ux times time of flight plus half ax times t square. So I have done nothing. I have applied the equation of second equation of motion along x direction. Instead of writing it as x sx, I'm going to write it as range r. Ux is nothing but u cos theta. Time of flight is nothing but 2 times of u sine theta by g, and there is no acceleration along x direction. So I've got my formula for range as well. Right now we have got like different formulas for range, different variations for range. One of them is this, right? The another one can be, I'll write it as 2, I'll write it as ux, this as uy, and divided by g. So one of the formula is something like this. The another formula can be, range can be written as, now please see, I can also rewrite it as 2 u square sine theta cos theta by g, and then using a slight trigonometric manipulation, I am going to write Instead of 2 sine theta and cos theta, I'm going to write it as sine 2 theta. So I'll write it as sine 2 theta by g. And over here we are going to also include a point to be noted, a note that let's suppose if u is constant, let's suppose that I can throw a certain particle with my maximum at a maximum speed of, let's suppose, 100 kilometer per hour, right? That's my maximum capacity of throwing a projectile. The only thing I can change is I can change the angle. So at what angle I should throw so that the range should be maximum. Okay, so for the maximum range we are going to use this, and we are going to say for maximum range, for maximum range, theta should be 45 degree. It makes sense. Why? Because if you want to make range as maximum, the only thing that you can change is sign. And for this sign to be maximum, this 2 theta should be something for which the sign gives the maximum value. Sign gives the maximum value as +1, and it gives it at, obviously we are talking about between 0 to 90 degree, right? So excluding the 90 degree angle, if we have thrown something at 90 degree, it goes in one dimension. So if this is 45 degree, this becomes 90, sine gives its maximum value, right? And that maximum value is u square by g. This is also something which is important. And you are going to, important and easy, nothing to worry about, right? You are going to actually use this somewhere or the other. Now the last thing that we have got over here is time of flight. Sorry, we have already done time of flight. The last thing that we have got over here is maximum height. So for maximum height, what we are going to do is, again we are going to use the equation along y axis, and now we are going to use the third equation. Vy will obviously become 0. Uy square will become u square sine square theta plus 2 minus g, and this would, instead of writing sy, I'm going to write h maximum. So h maximum will become, this will become u square sine square theta by 2g, or you can write it as just uy square by 2g. So these are the three formulas which are very simple for the first, what we can say, for the first case from ground to ground. Now we are going to look for certain questions also over here, but before that, now let's talk about what happens with the velocity and everything else, right? So before that, let's quickly see whatever we have done. We have talked about time of flight, and I've told you, whenever you want to solve anything in two-dimensional, in projectile in motion in a two-dimensional, right? If you're talking about x-axis, just concentrate on x-axis, apply whatever you know from one-dimensional motion, whatever you know from rectilinear motion, apply the same thing over here. Whenever you're going to talk about y-axis, do the same thing over there as well. So it's nothing new, right? So with this, now we have also find out what maximum height is. So now let's move on. So let's see some important notes now. The first note is speed, kinetic energy, momentum of the particle initially decreases in a projectile motion and attains a minimum value not equals to 0, and then again increases. What it is about, let's discuss. So let's suppose, now I'll again draw a diagram for all of you so that you can understand. This is, let's suppose this is ground. We have thrown our projectile from this point at a certain angle. Let's suppose something like this. right? So this was the initial velocity. The angle of inclination was theta. Now, please see that at the maximum height, we know that the only component of velocity is actually the horizontal component. Right? And this is actually Vx is actually equals to u cos theta only. And before that, if let's suppose this was uy, this was uy and this was ux will definitely not change, but at every point vy is actually the vertical component of velocity is decreasing. At the highest point it becomes 0. That means this is the minimum speed. How are we going to find out speed at any point? Let's suppose you want to find out speed at any point. So this is going to remain same. This is nothing but this is u cos theta. And let's say this is Vy. How are we going to write Vy? Although we are going to discuss it after some time, but let's just write it. So let's suppose at any time you have to write Vy at any time t. So it's quite easy, just use the first equation. So Vy will be actually equals to Uy, that is u sin theta, minus gt, that's it. And Vx will remain same, that is u cos theta. So speed will be nothing but the under root of Vx square plus Vy square. So that's what they were saying in that note, that speed is going to decrease till the maximum point and then again it will increase. Why? Because after this point the Vy will start increasing in magnitude in this direction. And at this point, the magnitude will again be equals to this. Let's say this is Vy dash. This will again will be equals to u sin theta. Obviously, the direction will be exactly opposite, and all along this will remain same. That is u cos theta. This will be nothing but this will be ux only. So please note everything. If you think that okay, you need to note all of these things down, please note it, right? So whatever I have said that magnitude of this component will keep on increasing after the maximum height. It will be again same as u sin theta. The speed will be again same as u. We are going to talk about this v dash. It will be again same as u, right? And so will be the kinetic energy, but it will not be 0. Momentum will also be not 0. It will decrease till the maximum height. Hopefully everything is clear. Angle between the velocity and horizontal first decreases to 0, then again it again increases in the negative direction, right? Also, there is also one more important thing. If you'll notice, at the maximum height, the angle between the acceleration and the velocity vector is 90 degree. So also you can remember this, that at h max, let's just write it as angle between velocity and acceleration is 90 degree. Is that correct? Right? Let me also write some of the important points for you. Although these things now you can consider these to be as part of your notes, or these might come up in some questions as well. What are those things? Let's suppose someone says two projectiles. For two projectiles, they have got let's suppose they have got equal time of flight. You have got two projectiles A and B, and they have got equal time of flight. What does it mean? Well, it just means that they have got they have got equal vertical component of velocity initially. Is that correct? Because this is nothing but this is 2 uy is equals to 2 uy right. So if this is the case, then we are going to say that maximum height attained by these two particles will also be same, because maximum height also depends only on the vertical component. So these are some of the quick facts. Quick facts you can include in your notes to speed up your calculation, right? Next thing is, if let's suppose someone talks about for theta equals to 45 degree. So we know that this angle is for maximum range. Right? What are the facts do we know, and we can note it down from here. So we know that range can be actually written as u square by g. This is one thing. We can also write this is going to be your range. If we want to write out the maximum height, because basically both of range and maximum height have got same dimensions, so let's compare them. Maximum height can be actually written as, it was u square sine square theta, isn't it? Sine theta would be 1 by root 2. So and by 2g. So by this logic we can write it as u square by 4g. Is that correct? Now let's compare them. So this will imply that maximum range is actually 4 times of maximum height. Obviously, we are talking about at 45 degree. So please remember this thing as well, right? Very important. Done? Hopefully everything is clear. In case they say that range and maximum height are equal, they might say something like this as well, right? So in case they say that, okay, let's suppose that range and maximum height are same for a particular case. This is another case. So I have listed 3 cases for you. There can be more than these 3 as well, right? So range basically means 2 u square sine theta cos theta by g. H max basically means u square sine square theta by 2g. So I can cancel out this u square, I can cancel out one of the sine. So I'll be left with, this will become, g can be cancelled out. So this will become tan theta will become 4. So theta will be tan inverse 4. And tan inverse 4 is, I think, around 75, 76 degree. So you can also remember this thing. Alright, obviously that is part of another thing, so don't mix them. So you can mention all of these things also in your notes. Right? Now let's move on. Let's move to some different topics, like if you want to find out the coordinates of a particle after a given time t. Now I have drawn the projectile motion diagram multiple times. Now if you have any doubt, please draw it by yourself and cross check, right? So I'm not going to again draw it. So if you want to write down the coordinates of a particle after a given time t, what I'll do is I'll go back to one of the diagram that we have drawn. this one. Let's suppose you want to actually find out the coordinates of this point. Let's suppose at time t the particle has reached over here and the coordinates is x comma y, right, at certain time t. So how are we going to write it? So we are going to write it as x can be written as u cos theta times time. Is that correct? Right? Well, there is no acceleration along x direction, so we don't have to worry about anything else. For y, we are going to write it as u sine theta times t minus half g t square. So it means that, this means that you're going to, the particle will be at y at two different times, right? At two different times, and it makes complete sense because if this is a certain point, so if you are going to draw parallel lines, something like this, again this point will also have coordinates as x dash comma y. So y will remain same, isn't it, at two different points. And also there is an important relation between the time. So let's suppose if this is time t1 and let's say this is time t2, t1 plus t2 is going to be the total time of flight. This is an homework for you. Write it down in your notes, this point that I have explained it to you, and figure it out, right? But this is very important. We are going to actually save a lot of time if these tips, if these notes are going to be on your fingertips, right? You are going to save a lot of time. So now the thing is, we have already found out how to write coordinates of a particle after a given time t, right? Let's also talk about velocity and direction of motion after a given time. So we have already written how to write velocity, right? Velocity is, let's say, Vx will always remain same. It will be always u cos theta, and Vy will be actually uy minus gt. So these are the two things that we need to remember. And if let's suppose that at any point the velocities are something like this. See, there can be two things. One is velocity can be something like this. I'm not drawing the whole diagram again and again. So this is nothing but this is ux, this is vy, right? So the net velocity is going to be this, and let's say this is v, and let's say this is alpha. So tan alpha will be Vy, which is actually uy minus gt whole divided by ux. So this is your tan alpha for finding out the direction. Similarly, you can do it if the Vy is vertically downward. Same thing will happen over here as well, right? So no issues. Obviously, for finding out the net velocity, that is speed, all you need to do is you need to actually write Vx square plus Vy square, and you have to put the values, right? So not so difficult. We have talked about, you can, this was related with time. You can also talk about for height. Then you are going to use the x, then you are going to use the third equation. Is that correct? So at any height h, you are going to write Vy square is actually equals to uy square, and let's say it is at a certain height h. So I'm going to write minus 2gh, right? For Vx, again, you don't have to worry about it. It will be just ux, that is u cos theta. And same thing, you're going to repeat it. So I'm not again and again writing and drawing the vector diagrams. It's just how you use the equations of kinematics. That's it, right? Pretty easy. Hopefully it is easy. Equation of trajectory, you might come across certain questions in exams like NEET from equations of trajectory as well. A very easy thing. Till now, what we have done is we have always related the velocities with either time, or we have related time with x or y. Is that correct? The second equation does the same thing. What does the second equation do? Second equation is something like s equals to ut plus half AT square, obviously in vector form, right? So, and when I am writing it as x, I can write it in x direction, I can write it in y direction, right? What I really want now is, I want to have a relation between x and y. Let's suppose till now, if I'll give you time t, you were able to find out the position of the particle. You can find out x and you can find out y. Just now we have done it, right? Now what I want is, if I'll give you x, can you find out what y is? That's what equation of trajectory will do. Equation of trajectory basically means equation of path. Trajectory basically means path. So now, so the thing is quite simple. We know that x can be written as u cos theta times t. T is any general time, sorry. Y can be written as u sin theta into t minus half gt square. Now, please remember what I told you. I told you I want the relation between y and x. So that means I really don't have anything to do with this t time. Na? So simple thing, let's, from this equation, let's find out the value of time t. Time t is actually nothing but x divided by u cos theta, right? So if this is the case, let's substitute it over here. So I'm going to rewrite y equals to u sin theta into t. So t is nothing but x divided by u cos theta. U can be cancelled out, minus half g, and instead of t I'm going to we have to write t square, so we are going to square that thing over here. So x square divided by u square cos square theta. Hopefully everything is clear over here, right? This thing can be written as tan theta, right? And I can also make tan theta over here. So please see a very simple manipulation over here. So what I'm going to do is, I'm going to actually write, what I'll do is, I've got cos square theta over here, right? So I'll write one sin theta over here. Obviously I can't do something like this, so I'll again write sin theta in the numerator as well, right? And instead of this cos square theta, I'll remove this one of the cos from this, and I'll write that one extra cos theta over here. Now please see, again this thing can be actually written as y equals to x tan theta minus, this g can be written in denominator obviously, so this thing can be written as 2 u square sin theta cos theta. That g which was in the numerator, I can rewrite that thing over here. Can you please see? I mean, this thing resembles a certain formula, right? Range. And what we have got one sin theta over here, and we have got a cos theta over here, which can, again, we can rewrite it as tan theta. So that's it. Now, let's come back. Now we are going to take out that x tan theta. That will be 1. We are going to write a formula something like this. So this is a very useful formula in a very simpler form. So please remember it like this, and also remember the process. I mean, there is nothing to remember it, right? If you know that, okay, this is what we are trying to do. The problem starts when you really don't know what you need to do and you start to mug it up. When you start to actually memorize it, okay, what was equation of trajectory? Okay, we put it, we find out t, then we put it over here, then we find out the equation. Okay, this is what we call as equation of trajectory. Okay, now let's move to the next topic. So in this way, you'll always forget it. Whenever you're going to, whenever it's going to be a little while that you have studied a particular topic or a chapter, you're going to you're not going to remember these things, right? So the first thing is, find out the motive, find out why we are doing a certain kind of a thing. Then the main part is to remember this formula, right? To not make a goof up over here, because when you are going to have a questions on equation of trajectory, it is very important that you don't derive it at that point, right? Sometimes students think that, oh, I am so good in derivation, I am going to derive it in the actual exam, and this is going to actually cost you I mean at least two question time, right? So don't do that. So this is your equation. Hopefully we have written it absolutely correctly. Now let's move to the next topic, and it is when two projectiles have equal ranges. This is actually also you can include this thing in your notes. Well, when we are saying that when projectiles have got equal ranges, it just basically means that, let's suppose we have got two projectiles and these are thrown at the same speed. I'm going to also let you know this thing. The thing is, the formula for range is actually 2u square sine theta cos theta by g. This is the formula, right? So if you have thrown a certain projectile at an angle of theta, the complementary of that angle the new range will become 2u square sine alpha cos alpha by g, and this will become 2u square sine 90 minus theta cos 90 minus theta divided by g. 90 minus theta is cos 90 minus theta is sine, the complementary functions. So it would remain same. This is the only thing that you need to remember. Obviously, you don't have to do all of these things. You just have to remember that range for the only thing that you can write over here is that range that we get for a certain projectile. Obviously, we are not changing the velocity, right? The initial velocity. We are just changing the angle. This is going to be same as 90 minus theta. You can rewrite this thing. Hopefully everything is clear till here, right? Now let's start with some questions, and that's what I said in the beginning of this class. It is very important to also, we are going to also talk about some questions in this class, right? So before starting solving the questions, please pause the video. I'll step aside so that you can clearly see this question. Please pause the video and solve it by yourself. Even if you are not able to solve it, okay, fine, unpause it and then see my solution and figure it out where you have done the mistake, right? It says, the question says, a particle starts from the origin at t equals to 0 with a velocity of 10 j cap meter per second and moves in the xy plane with a constant acceleration of 8 I cap plus 2 j cap. See what they are talking about. They are saying that we have got a particle that starts from the origin and it has got velocity. That means the initial velocity vector is something like this. 0 I cap, there is no velocity in along I cap, 10 j cap meter per second. And acceleration is a constant acceleration of 8 I cap plus 2 j cap meter per second square. The y coordinate of the particle in time 2 seconds is. Now this is not case 1, this is not ground to ground, right? This is not ground to ground. Why? Because generally when we are talking about, well, it can be considered as a ground to ground because it has been thrown from the origin, but not what we have done right now. Because in our case, there was ux, there was uy. Right now here we don't have ux over here. In the case that we have just did right now, we didn't have ax. Right now we have, right? So if you have got ax, you have got ay, both the components will change. So if you want to find out the y coordinates, please don't worry about the 8 I cap. It has got to do nothing with the things that is along the x axis, right? So we have to just write for y coordinate at 2 seconds, we are going to write y equals to, right? Y equals to uy into t plus half ay into t square. That's it. This is what you need to do. So uy is actually 10 times 2 plus half, ay is 2 times square of 2. So this is going to be 24 meters. That's it. So this was not a difficult one, but yes, you can expect questions like this in NEET exam, right? Moving on to the next one. Again, do the same thing, my friends. Solve it by yourself. Unpause the video. Check the solution. If you have done any mistake, write down that mistake as well. The question says a projectile is thrown with a velocity of 50 meter per second at an angle of 53 degree. Okay. So this is an x-axis. This is y-axis. So the projectile is thrown at an angle of 53 degree. And the velocity is 50 meter per second. And they are talking about, I can see they are talking about in vertical and horizontal components. So this is going to be nothing but 50 cos 53. Cos 53 is 3 by 5. So this is 30 meter per second. Uy would be actually 50 sine 53, which is 4 by 5, which is going to be 40 meter per second, right? Now let's see, it travels vertically with a velocity of 40 meter per second at all times. Sometimes they also don't write this at all times, right? And you have to find out the incorrect statement. This is very important. This is very important that you have to find out the incorrect statement. So this is the incorrect statement. Obviously, the first one is the incorrect because this will actually change. The vertical component changes because of acceleration due to gravity, right? It travels horizontally with 30 meter per second. This is correct. The minimum velocity of the projectile is 30 meter per second at the maximum height. This is also correct. So the only problem we had in these four options is that it does not move with 40 meter per second vertically at all times. Even if they have not written at all times, then also you are going to opt A as the answer. The next question again, my friends, pause the video, unpause it, check it. A projectile is thrown with a velocity of 50, so it is just part of the same thing. We have to determine the instant at which the projectile is at the same height. Do you remember? We have actually talked about it, right? So let's find out the time of flight for this. Let's find out the time of flight because I've told you the trick. If you remember, the time of flight is going to be 2u sine theta by g, and we have already find it out that it was actually 40 meter per second divided by 10. I'm going to take it as 10, right? So it is going to be 8 seconds. So 8 seconds. Now 1 plus 7 is 8. So this is going to be the answer, which, and second one is also, and so is the third one. So that means D is going to be the correct answer. You can check it. You can check it, like find out the y at 1, find out the y at 7, do the same thing for 3 and 5, do the same thing for 2 and 6 if you have got lots of time in the world. But in exam, in your mock exams, in your test papers, anywhere when you want to actually when you have to be speedy, please just remember all of these things, right? Moving on, the last, I think probably the last for this passage type question. Same thing, we have to now find out the equation of trajectory. Do you remember? So equation of trajectory, now I have told you to quickly rewrite the equation of trajectory as x tan theta we know what tan theta is, 1 minus x upon r. Do we know what r is? Yes, we know that range is actually 2 ux uy by g. So it would be 2 times of 30 times 40 divided by 10. Is that correct? So this is going to be 240. This is 240 meters. So y equals to x, and tan 53 is actually 4 by 3, 1 minus x upon 240, my friends, right? So if I'll actually do it, you know what? We are going to write it as, let me see, okay, we have got in this form. So this is going to be y equals to 4x by 3, and this is going to be 240 minus x divided by 240. So I can rewrite this thing as, obviously this thing will be 60. So this thing will be 180, and this is going to be 180 y, right? 3 times 60 is 180, 180 times y is 180 y, and that would be 240 x minus x square. So this is going to be your answer. So 180 y equals to 240 x minus x square. That means A option is the correct. Right? Hopefully everything is good. Let's move to the next one. A particle is projected from a horizontal plane xz plane such that its velocity vector at any time t is given by a I cap plus b minus c t j cap. Its range on the horizontal plane is given by. All right, please remember that a particle is being projected by this vector at time t, and we have already got what velocity vector is. It is given as a I cap plus b minus c t and j cap. Now I want you to really do it. This is an xz plane, and you have to find out the range of this particle. Pause the video, solve it, and then after you have solved it, I'll solve it. Now let's see. let's not worry about that. Okay, we don't have an acceleration, although we can find out acceleration over here as well. And let's not worry that, okay, this is an XYZ plane, how we are going to find out the range. See, we know one thing, that for finding out the range, usually what we do is, we write for xz plane, we are going to write range will be actually velocity in x direction times the time of flight. And for finding out the time of flight, what we are going to do is, this velocity will become 0 at a certain point. So this velocity will become 0 when b minus ct will be 0, and that time will be b by c. So from here we can say that time of flight will be 2b by c. So this is, and velocity in x direction is a times 2b by c. That's it. This is your answer, 2ba by c, or 2ab by c. 2ba by c is the correct answer. That's it, right? If you want to find out the acceleration in x direction, that is going to be dvx by dt. So that is 0 because a is constant. If you want to find out the acceleration in y direction, that is going to be, this will be 0, this will be minus c meter per second square, right? So now after this, hopefully you have got it. I can also give you 1 or 2 questions in homework, and write down the answers in the chat box. So 2 projectiles A and B thrown with same speed, okay? Do this one in homework. And one more in homework. So last 2 questions I'm giving you in homework. This is, I think this is from the tower, na? So I'll solve it with you. But first let's discuss this case, because right now we have not discussed from the height to ground. When we are going to talk about the height of ground, in this also we are going to talk about two different cases. And the two different cases are going to be something like this. The first is going to be when we are going to say that we have got a projectile and we are throwing it from a top of a tower of height h, and we are throwing it horizontally. Now what does horizontally means? Horizontally basically means that the projectile, so in case 2 itself we have got another case when the projectile is being projected horizontally. That means theta is actually equals to 0 degree. Now you must always remember what do we really mean by theta. Theta is just the initial angle between the velocity and the x-axis. So this is the velocity, this is the net velocity, let's say it is u, right? So the path will be something like this. We can always extend this. Something like this, right? Same thing, no difference. Let's say height is h. So at any point if you want to find out, write down the velocities vectors, this will always remain u. We can find out what this Vy is, right? At this point also you're going to have the component over here as u. We can find out what this Vy dash is going to be, and we can also find out what this net velocity is going to be, and this angle as alpha, right? We can do all of those things. And if you want to actually do all of those things, what you can do is, generally this h is given. So if you want to find out the time, so for finding out the time, what we can do is we can write Sy equals to Uy into time of flight minus half Ay into t square. So we know that there is no initial velocity in y direction. Is that correct? Uy was 0. There is only ux. That's what horizontally thrown means. So by this logic, and instead of Sy, I am going to write minus h. So minus, by the way, this was plus, Ay is negative. So this will be your time of flight. So time of flight is going to be 2h by g. And after finding out the time of flight, you can find out this range as well. Right? And range will be calculated as u times 2h by g. And if you want to find out the velocity at any point, again, same things are going to be, we are going to apply the same things again, right? So this u will never change. For Vy, you can use the first equation or you can use the third equation. The another case over here is, if the particle is thrown at an angle, that means we have got a tower which is on a ground, of height h. This is a line parallel to horizontal axis, and the projectile is being thrown at an angle, something like this. Let's say this is theta. So now the projectile will first attain a height and then it will fall back. Something like this. Although there is no big difference over here as well. So for finding out questions like this, all you need to do is the displacement. Please hear me out carefully. This is initial velocity, this is theta, right? The displacement traveled along y direction is still minus h. Why I am calling it as minus h? Because I always take the negative downward axis as negative, right? So this is minus h. So all you need to do is just apply the same thing over here. Now the initial velocity is u sine theta. So I'm going to write minus h equals to plus u sine theta times time of flight minus half g t square. So from this equation you can find out what the time of flight is going to be. So obviously you can't have a formula over here because it will come out to be a quadratic, but you can easily find it out. After this you can again rewrite the range as u cos theta, because it will not change, times time of flight. And for finding out the maximum height over here, what you need to do is, for finding out the maximum height is actually again 2. If you're going to see this is actually the maximum height. So this is actually 2 uy square by g, sorry, uy square by 2g, and plus the height of the tower also, right, which was actually capital H. So that's it. Hopefully you have all done it. Now after this we can actually solve this question. Again, please, I want you to actually pause this video right now and solve it by yourself. A ball is projected from top of a tower with a velocity of 5 meters per second at an angle of 53 degrees to the horizontal. Its speed when it is at height of 0.45 meter from the point of projection. All right, from the top of a tower, and we don't have the height of the tower and we don't need it. So all we need to do is we need to just use the equation. We have to find out the speed. Now please see, we just have to find out what Vy is going to be. So Vy is going to be Vy square equals to Uy square plus 2Ay into Sy. So Vy square equals to Uy. What is Uy, my friends? Uy is going to be 5 sine 53, that is 4 by 5, that is 4. So this is going to be 4 square of 4 plus 2 times of minus 10 times 0.45. Is that correct? Right? So this thing will be 9. So this is 16 and this will be minus 9. Hopefully everything is clear till here. Is that correct? So this is going to be 7 meter per second, and ux is actually 5 times 3 by 5, right? Cos 53 is 3 by 5, which is going to be 3. So the net speed is going to be 3 square is 9 plus Vy square is 7. So which will again be 16, that is going to be 4 meter per second. So this is going to be the answer. Hopefully you have got it. Right? Now let's move to the next topic, which is one-dimensional motion, relative motion in one-dimensional motion. Although we are going to talk about relative motion in soon, we are going to start river man problem and we are going to talk about rain man problem, but let's start it with relative motion in 1D. And I have also actually explained a little bit of relative motion in kinematics, one-dimensional, right? But let's again study it. And I'm going to also explain a little trick to you how to solve problems like this. Let's suppose we have got two bodies. On a ground, body B and body A. This is moving with a velocity of VA at this point. This is moving with a velocity of VB at this point. And it has got an acceleration of AB. It has got an acceleration of AA. I'm going to write all the vector quantities VA, VB. Let's not talk about acceleration. Let's just talk about the velocities. It would be easy for us to understand, right? And all of those questions in which they say that find out when this particle will chase the another one, when someone will chase it, or when this car will actually overtake the another car, all of these questions will be easily done by the relative motion and by the trick that I'm going to explain to you, right? The thing is, the trick is, if you want to find out, let's say that this is moving with 20 meter per second and this is moving with 30 meter per second, and the initial separation between them is, I'm starting with the easiest example, so don't worry about it. I'm deliberately starting with the easiest example because I'm explaining to that student who is studying for the first time or who is not able to understand the concept of relative motion, right? First, let's understand this thing with a trick, then we'll talk about all the mathematical equations, and we are going to write the relative motion equations and all of those things, right? Let's suppose that the initial separation is of 100 meters. And I want you to calculate the time. We want to find out the time after which A will overtake B. Find out the time and also we can find out the position. So what is the traditional way? The traditional way is you are going to say that, see sir, obviously it is at 100, it is 100 meter far away from this. So it will collide, it will actually overtake B at a certain point into the future. Let's suppose that is that point, and let's say that at T time A overtakes B. So at T time, let's say sir, this is the distance traveled by Bx. So B will travel X distance in T time, and in the same T time A will travel 100 plus X. We are going to equate those equations. Don't make me do all of those things, right? Try to understand it and do it by yourself. I'll explain the trick. In T time, B will travel X distance, and in the same T time, A will travel 100 plus X distance. Is that correct? And we'll equate those times and we'll get our answer. But obviously that is a long way. If again we'll include acceleration, then it will become even longer, right? So now what I'm going to do is, what the trick is actually, let's make the same diagram in our relative world. What is our relative world? I'll explain it to you. Let's suppose we are assuming that B happens to be at rest. You are going to say, sir, it is not possible, B is not at rest. That's what the trick is. Let's suppose that B is at rest. If you want to make B at rest, what do you need to do? You will say, sir, actually we would want that this 20 meter per second becomes 0. I say, okay, fine, that makes sense. So for doing that, can I say that this, I'll add a velocity vector in the opposite direction, and that velocity vector will be of 20 meter per second. So that what will happen is the net velocity of B will become 0 in my relative world. Is that correct? Right. So now this, its velocity in my relative world becomes 0. Obviously, I just can't do this thing for only B. So I'm going to do the same thing with A as well, because that's what I'm saying, na? I have to change, I'm changing this in my relative world. So again, I'm going to do the same thing. So this is also 20 meter per second. I'm going to add the same thing over here. So it will try to cancel it down, but now VAR will become 10 meter per second. Now in our relative world, B is at rest. It is not moving. So it means that if B is not moving, this 100 meter will only be changed because of this velocity. So the answer is going to be, the distance is 100 meter, the velocity is 10 meter per second. So the answer is 10 seconds. So after 10 seconds, it will overtake. I know it is a very basic level question, but as you are going to move into more difficult and complex problem, the essence, the concept of relative motion will remain same. It will not change, right? You can do the same thing with acceleration as well. If let's suppose it started with certain acceleration, it has got certain acceleration of 2 meter per second square, and it has got certain acceleration of 3 meter per second square, or any acceleration, and they say what should be the minimum distance so that it can actually catch B. Again, do the same thing with the acceleration as well, right? Hopefully you are able to understand what I'm trying to say. Now the thing is, in relative motion, how we write it in mathematically. So you remember that I'm going to now actually, I want you to look at the original diagram. VB is along that, VA is along that. So if I'll ask you, what is the velocity of B with respect to A? This is actually what we have done. So this is being read as velocity of B with respect to A. It will be equals to VB minus VA, where VB and VA is, this is velocity of B with respect to ground, which can be also called as absolute velocity of B. Although absolute velocity does not mean anything, but yes, we are assuming that ground is at rest, right? And this is velocity of A with respect to ground. Now please mind this thing, that I have written vector sign, so all sorts of things are possible. So you have to put the values according to the sign, whatever sign you are going to write, right? So similarly, you are going to say that, okay, if this is true for velocity, then acceleration is also a vector quantity. So acceleration will be written as, similarly, I mean, B, I am writing it as B, so okay, over here I also write it as B, and no worries. It will be written as acceleration of B minus acceleration of A. And same thing goes for, if you want to write it for like VAB. So please remember that VAB is nothing but negative times of VBA. It is true for displacement as well. Right? A very important thing to understand. And please try to understand how we are going to solve problems like this. And if you remember, we have got a question something like this, that let's suppose we have got an equilateral triangle, and this initial side, the separation is actually A, and actually they don't say it is an equilateral triangle. What they say is that we have got three particles at A, B and C. We have got three particles A, B and C initially placed at the vertices of an equilateral triangle, and they are moving in such a way that first of all they are moving towards adjacent particle in counterclockwise direction. All the times. What do you mean by this? I'll explain it. With initial velocity, let's say u. So B is moving towards C, C is moving towards A, and A is moving towards B. That's what the counterclockwise would mean. Is that correct? Now it means that as soon as C moves, I'm just talking about C, as soon as C moves over here, now the B will actually change its path and it will start moving in this direction, and also C will start moving in this direction, and again the A will start moving in this direction. Hopefully you are able to understand it. Right? They will not keep on moving in circles. I have not said it that they are going to move along the triangles. They are actually trying to move. They are trying to move towards their adjacent particles. Right? So again, after some time, they will change their direction and eventually they will actually meet at a certain point, something like this. We have to find out this time. Now, for solving questions like this, relative motion is actually a blessing, right? And for solving many types of questions, relative motion is actually a blessing. So now what we are going to do is we are going to just look for two particles A and B and at their initial point, initial start. We know that this angle is 60 degree. This velocity is u. This is also u initially. So the component of this u over here on this axis is actually u cos 60. U cos 60. So let's do one thing. Let's make this B at rest. Right. So for making this B at rest, we are going to subtract this u cos 60 on this plane. So u cos 60 gets subtracted. So and see how I'm going to write it vectorly. I'm going to rewrite it as velocity of B with respect to A will be actually u, that is velocity of, let's do one thing. Let's rewrite it as UAB. So it is going to be u minus, and I'm going to write minus of u cos 60, and I'll explain it why. See, I am assuming this direction to be positive. Please understand, I am assuming this direction to be positive. So the opposite of this direction is going to be negative. So u cos 60 I have written with a negative sign. So this is going to be actually u plus u by 2, that is 2u by 3. Is that correct? Please understand, this is u, this is u by 2, this is 3u by 2, sorry, 3u by 2. Right? And now it's quite easy. The time taken for this to happen is actually, the distance is a, the speed is actually 3u by 2. So this is going to be the time. So you can solve questions like this, right? So obviously it is a little, difficult to really imagine how this will happen, but exactly in this time they all three will meet over here, right? Now let's move to some more problems, and those problems are actually related with, let's first start with river boat or river man problems, right? Let's start with river man problems. This is actually a case of relative motion in 2 dimensions. Not that difficult if you are able to understand the basic terms, and again we are going to use the concept of relative motion and we are going to use the concept of 2-dimensional motion. What are the different things? Let's try to understand. The thing over here is, let's suppose that we have got a river flowing like this. So this is one of the bank, this is the another bank. Hopefully you know what bank means, right? And river is flowing something like this, let's say with certain velocity. So this is VR, velocity of river. Now it could be a boat, it could be a swimmer, it could be a man, doesn't matter. We have got river man or river boat or swimmer, whatever you want to call it. let's suppose that for me I'm calling this as a man. We have got a man over here and he tries to swim, and let's even before that, let's talk about more simple things. Let's suppose that we have got a river flowing at certain speed. At let's suppose the river is flowing with 10 kilometer per hour of speed, that we called as current of river, right? 10 kilometer per hour. So first of all, excuse me, first of all, what is this 10 kilometer per hour? This 10 kilometer per hour is actually the speed of the river observed from the ground. So obviously we have got ground over here. So these are the banks. This is the river. Over here we have got ground. Over here we have got ground. So 10 kilometer per hour is the speed of the river. Now we have got a man who thinks he can swim with 15 kilometer per hour of speed. That is his maximum capacity, 15 kilometer per hour. Please try to understand. This is 15 kilometer per hour. That's what he thinks, right? So this is going to be the velocity of man with respect to the river. Now, please hold on. I'm going to again explain it. Let's suppose the river was not flowing. If river is not flowing, we are going to also call it as still water. We are going to also call it as still water. Still water basically means the river is not flowing. So if river is not flowing, the man actually can swim with 15 kilometer per hour of speed. This is his maximum capacity, right? Or if you are going to ask man, obviously through a wireless mic, right? So if you are going to ask him that, okay, what is the speed, with what speed you are actually swimming? So he'll say that, see, obviously I can't measure my speed, but I am swimming with my maximum capacity, and usually when I do that, my speed is actually 15 kilometer per hour. So my speed would be 15 kilometer per hour. That's what he will say. And now we are going to say, obviously the river is also flowing at 10 kilometer per hour. So if someone is going to judge this man's speed, the swimmer's speed with respect to the ground, what they are going to actually say is that the man is actually flowing with 15 plus 10, that is 25 kilometer per hour, because of course with respect to the person who is at ground, who's on ground, they will also add the velocity of the river. And because the person is swimming downstream, that means he is flowing along with the flow of the river. The speed of the river will get added to the speed of the person. So now the speed would be 25 kilometer per hour. So this is the reality. Is that correct? So now we are going to do the same thing, but just now we are not going to talk about like downstream or upstream. We are going to talk about the two dimensions. Have you got my point? Right? So we are going to talk about actually 2 or 3 types of speed, and let's write them. I've explained one of the easiest example. So what are those speeds are going to be? We are going to actually talk about velocity of river. We are going to talk about velocity of man, and we are going to talk about velocity of man with respect to river. This is going to be velocity of river with respect to ground. This is going to be velocity of man with respect to ground. Sometimes they call this as absolute velocity also, right? And this thing will be called as velocity of man with respect to river. This is very important, right? Why? Because sometimes this is also known as velocity of man in still water. Does it make sense now? What do we mean by in still water? Right? Velocity of man in still water. Hopefully everything is clear. Right? So now what I'll try to do is, I'll say that, okay, let's suppose man is trying to swim from one bank to the another bank. Right? Also one more thing. Please try to understand. According to the equations of relative motion, we know that this thing can be written as velocity of, sorry, I should write it like this, mr, velocity of man minus velocity of river. Very basic equation, right? So because of this equation, what we are going to do is, it means that if I want to write velocity of man with respect to ground, what I'm going to do is, I'm going to find out the vector sum of these two things. Is that correct? Please look over here. This is the main thing. If I want to find out the velocity of man with respect to ground, all I have to do is, I have to find out the velocity of man with respect to river. I have to find out the vector sum of velocity of man with respect to river and velocity of river with respect to ground. This is the main thing, right? I'm going to draw the diagram again to the next slide. So let's not worry about over here, right? In this diagram, all we'll do is, we'll say that, okay, the width of the river is also given, the width between the two banks, and it is actually small d. It is small d. Is it clear? Let me draw the same diagram over here. I'll make a copy and I'll remove all of these things. Don't worry, you'll, and by the way, friends, you know how to actually download notes, right? If you you just have to log into PW app, and then you can buy this batch, and the cost is actually 0. It would cost you 0 rupees, and from that batch you can download these notes. So you have got everything over here written, right? Now please try to understand. What I'll do is, I'll actually, to reduce confusion, I'll draw it over here. And I'm saying that the person is trying to start to swim from this point, and I'm trying to draw a vertical axis just so that we can play with the components easily, right? Obviously, at this point, we know that the river is flowing with a velocity Vr at this point. So let's draw Vr over here. This is Vr. And I'm drawing VMR. Something like this. First of all, it's not about drawing a diagram. We'll also solve some questions, and I'll explain why do we draw diagrams like this. You can also draw VMR over there. So it's not really something like, yes, I mean, if you'll actually remember it like this, in majority of the books, you'll come across the same types of formula, right? So it's quite easy. Now try to understand what we are trying to do. For this particular diagram, it's not only this is the case, right? I'm not saying that this is the only case. There can be many cases. We are starting with one of them. For this particular case, I am saying that this is VMR. What do you mean by VMR? VMR basically means the man thinks that he is actually swimming at this angle from the vertical, at an theta angle from the vertical. This is what the man thinks, right? But the reality is actually that this is the reality. Velocity of man will be found out by the vector sum of these two quantities. This is very important. So if you want to find out the vector sum of these two quantities, the vector sum will be found out in between of this. So the man will actually land up, he thought that I would actually land up somewhere over here. But in reality, the man will actually land up towards the right of this point. Is that correct? Towards the right of this point. Now, how we are going to do it? First of all, what is the angle theta? So, right now the angle theta is, I'll also explain. Right now the angle theta is angle between vertical. When I say vertical, I mean vertical line parallel to y-axis, vertical, and VMR. That's it. Right? Also, one more thing. I know that I can write VMR as in component form. I can rewrite it as VMR cos theta, or I should write sin theta, and when I write sin theta, I'll write it with a negative sign. Please see, I'll write it as minus VMR sin theta I cap. Why I'm writing it as minus? Because I'll have a component of this thing somewhere over here. Right, so this is VMR sin theta. And I'm always I'm of course assuming this to be positive, this to be negative, right? And this is going to be VMR cos theta. Right? So VMR sin theta I cap plus VMR cos theta j cap. Now the thing is, if you are going to talk about what is the velocity of river in vector form, so that is VR I cap. And why are we writing all of these things? Because when we are going to talk about velocity of man with respect to the ground, we would write the sum of these two things. So we are going to actually add them. So we are going to write VR minus VMR sin theta I cap plus, we only have got over here as VMR cos theta j cap. That's it. So this is the final VM in vector form. Almost everything is being done now. How? I'll tell you. Now, what are they going to ask? They'll ask two things. After what time the swimmer will actually, he or she will, he will actually able to cross the river, right? Reach to the another bank, find out the time. The next thing is find out the what we can say, find out the drift. What do you mean by drift? We'll talk about it. So let's suppose, according to him, he was about to reach over here, but in reality, let's suppose he reached somewhere over here. So this is going to be the drift, right? The displacement is going to be called as the drift. Now the thing is, if I want to find out this if I want to find out the time to cross the river, So this d dimension is along the vertical axis. Please, again, in this class only we have talked about the two-dimensional chapter, right? So d is along the y-axis. So out of these two components, which is responsible to take the swimmer to the another bank? Obviously VMR cos theta. So I'm going to write the time as the distance d divided by VMR cos theta. That's it. This is the time, right? And if we want to find out what this x is going to be, that is drift. Obviously, I have not added that V, or I have not drawn the vector. I don't really need to, right? If I want to find out this drift, so that X is going to be in the same time, in this same time, the person will also get drifted, the swimmer will also get drifted, and the velocity which is responsible to move in X direction is this. So I'm going to write VR minus VMR sine theta times time, that is D divided by VMR cos theta. Is it clear? Right? Now, obviously, we have got some special cases over here. Those special cases is, we have got two types of cases. Case 1 for minimum timing. What do you mean by minimum timing? That case 1 is, what is the condition for which, or what are the things for which the person will reach to the other bank in the least time, right? So this is for minimum time. Minimum time to cross the river. So for this, we are going to say, okay, so for T to be minimum, we know that the formula was D upon VMR cos theta. So if T should be minimum, this should be maximum. The denominator should be maximum. And the maximum value of cos theta is actually plus 1 at 0 degree. So this is going to be D divided by VMR, and this will be at theta equals to 0 degree. This is the minimum time case. Please remember, this is the minimum time case, but at this, for this time, obviously the drift will not be minimum. There will be some drift, right? This is absolutely true. And you can quickly find out what that drift is going to be. This is for case 1. Now for case 2, that is for minimum drift, that is drift equals to 0. For minimum drift. And by the way, one more thing, when I say drift, this is not drift. Drift is actually, I want to actually rectify one thing. We actually call drift as this, from the point where it has started. So it is actually a big change. So please note, this was my bad. This is actually the drift, right? The point, it has started its journey, but it will reach to a different point, right? So minimum drift. So minimum drift would basically means that X would be equals to 0. That means when we say minimum drift, actually we are talking about, okay, we have started from this point. If we are going to, if we'll be able to reach at the same point, that would be the minimum drift at the same line, right? Obviously at that point the man will actually try to move at a certain angle, because velocity of river will also get added, and then the person will be able to reach at this point, which is going to be the minimum drift case, right? So pardon me for that. So for minimum drift, I'm going to just say that if X should be minimum, this was minimum when VR minus VMR sine theta times D upon VMR cos theta. This should be actually 0. Now please try to understand. This is time. This thing is time. It can't be 0. Time can't be 0. So for drift to be 0, this term should be 0, which means that for minimum drift, VR should be actually equals to VMR sine theta. So sine theta would be actually equals to VR divided by VMR. Now from here we'll have some different things as well, which basically means theta would be sine inverse VR by VMR. So if the person is going to swim at this angle, then there is a possibility that there will be minimum drift. Why I am saying possibility? Because there is also one more condition. You must be, obviously you know that if this is sine theta, this value should be less than 1, right? And if this should be less than 1, then this is only possible when VR is less than VMR. This is the condition for minimum drift. Even if they are equal, the angle will become 90 degree. And if the angle, even if they are equal, right? Yeah, they will become 90 degree, and we can't say, we won't be able to say, please try to understand this thing. If this value is greater than 1, that means no such angle exists. No such angle exists. This is what I am trying to say. Look over here. If this theta is, if sine theta is greater than 1, then there is no such angle exists for which the person can actually reach to the same point. And you can actually understand it in such a way that if VR is too large, I'm explaining it practical wise, if VR is too large, it would be practically impossible for the person to reach to the diametrically opposite point. That would be practically impossible, right? So it actually explains the same thing over here. Hopefully you have got it. All right. So remember all of these things. Now let's start with 1 or 2 questions on the same thing. Let's see this one. The question says a boat having a speed of 5 km/h in still water. So this is your VBR. Now they are talking about boat. So we are going to write VBR. This is given as 5 km/h. All right. Crosses a river of width 1 km along the shortest possible path. So for shortest possible path, time is 15 minutes. That is 1/4 hour, right? And 1 kilometer divided by VMR cos theta. So we know what VMR is. This is 5. So cos theta would be 4/5. That would mean that theta would be 37 degree, right? And if it has to travel for the shortest path, that means VMR sine theta should be equals to VR. They should cancel out each other. So we know that this is 5. This will be 37, means 3/5. This is going to be VR. That is 3. Right? Please try to understand, if the man has to reach to this point, these two velocities should cancel out each other. Very easy, right? Now I'll give 1 or 2 question in homework. Let's see this one. A man is crossing a river flowing with a velocity of, so you know what VR is now. VR is 5 meter per second, right? He reaches a point directly across at a distance of 60 meter in 5 seconds. Again, so you know what time is. Time is 5 seconds. And this is 60 meters divided by VMR cos theta, right? So VMR cos theta would mean 12. Also, one more thing. What else we know? He reaches the directly to that point, right? So for zero drift, we know that VMR sine theta would be actually equals to VR, and VMR sine theta can be written as VR, which is given as 5, right? So this is 5 and this is VMR cos theta. Divide them, make a right angle triangle, right? So the right angle triangle would be something like this. Tan theta would mean that perpendicular, tan theta would mean, my friends, this is 5, this is 12, this is going to be 13, right? And now they are asking that his velocity in still water is. So now you can find out what VR is going to be, right? So complete this. Now I am going to complete this chapter after finally when we'll finish Rain Man problems also. Now in again Rain Man problem, the basic concepts is going to remain the same. Whatever we have started, whatever we have talked about in relative motion, that is VAB can be written as VA minus VB, all with vector sign. Same thing we are going to do over here as well. The simplest case can be when the person is at rest and the rain is appearing to fall vertically. This is ground. We have got a person over here and the rain is appearing to fall vertically downwards. This is the easiest problem. I mean, this is not a problem, this is just an example. So again, we are going to talk about velocity of man, which in this case is 0. We are going to talk about velocity of rain. And in some another cases, we are going to talk about what is velocity of rain with respect to man. This is very important. So this is going to be velocity of rain minus velocity of man. Please try to understand this thing. You must be knowing that in this type of problems, they ask that at what angle the man should hold an umbrella so that the person should not get drenched. That means the person should not get wet, right? So the angle at which the person will hold an umbrella will be actually dependent on VRM, because that's what the person thinks that the rain is falling at such an angle, right? So we must find out what VRM is. Now let's suppose in another case, this person starts to run. In some another case, the person starts to run with the velocity of Vm with respect to ground. Now what will happen? See, so now we have got velocity of rain which is falling something like this, and this is the velocity of man. But what we need is, we need minus Vm. So we are going to actually write minus Vm, something like this. And this is going to be your vector Vrm. And this is going to be the angle at which the person must hold the umbrella. So tan alpha would be Vm divided by Vr. So the same thing, same formula, everything is same. You just have to apply the concept again in such a way, right? So at this angle, the person must hold the umbrella. All right. So we have got one question over here as well. Hopefully we have got one question. Let's say this one. The question says a man is walking due east at the rate of 2 km/h. The rain appears to him to come vertically. Now please understand, when they say the rain appears to him, that means this is the direction of VRM. Velocity of rain with respect to man. This is VRM and this is given as 2 km/h. Right? All right. The actual velocity and direction of, now see, this is actually quite easy. We know what VRM is, right? And we know what velocity of man is. So this is velocity of man. And we know that velocity of rain with respect to man is actually velocity of rain minus velocity of man. And if you want to find out velocity of rain with respect to the ground, all you need to do is you need to just add these two. That's it. And this is also actually 2 km per hour. So this is going to be the actual velocity of rain, which is actually 2 root 2 and at an angle of 45 degrees from the vertical. So 2 root 2 and at the angle of 45 degrees from the vertical, right? So I have given you two homeworks, although I have almost solved this question, right? I have almost solved this question. So complete this one and I'll give you one question in homework for the rain man problem, right? So this one is also in homework, but there's no new concept over here. And hopefully after this, you will have a pretty good idea how we are going to actually solve questions in two-dimensional motion. After this, if you have any more doubts, please write down your doubts in the comment section. I'll get back to you. And next week, I'll come up with the next chapter, that is Newton laws of motion. So thank you so much. Take care. Best of luck for your preparation. I'll see you next week. Bye.